Okay, let's have a look at what we have already in differentiation. So these are the rules that we've been using. So when we have something like x to the power of n to differentiate, we just get nx to the power of n minus 1. So something like x squared will differentiate to give us 2x to the power of 1. If we have ax to the power of n, that differentiates to give us n times a x to the power of n minus 1. And if we have a constant, that differentiates to give us 0. So we're going to give you 3 more rules now that we can use when we're differentiating certain types of functions. And the type of functions that we're going to look at now are trigonometric functions. So things when we have sine, cos, and tan. So the first rule I'm going to give you is the rule for sine x. So if we have a function f of x is equal to sine x differentiates to give us cos x. So it's fairly straightforward. You could do this by first principles, differentiate sine x by first principles, and you will get cos x. If we have a function f of x equals cos x, well, cos x differentiates to give us minus sine x. And the third one that we're going to look at is tan x, and tan x differentiates to give us this sec, I'll explain this in a minute, sec squared x. Okay, so these are very, very straightforward. Let's have a look at the tan x function first of all. So tan x differentiates to give us sec squared x. Sec is very, very simple. All it is, let me see it right here, sec of x is just equal to 1 over cos x. Just very straightforward. That means if we have sec squared x, that's equal to 1 over cos squared x. And then this notation, cos squared or sec squared, you mightn't know either. If I write, if I write cos squared x, that just means cos x multiplied, it means cos x squared. So it's just a shorthand notion for writing cos x squared. So I just write cos 2 up here, x. I just don't need the brackets. Okay, so go back to this. So when we differentiate sine x, I get cos x. When I differentiate cos x, I get minus sine x. And when I differentiate tan x, I get sec squared x, which is just 1 over cos squared x. It just means the same thing. Let's look at a few examples of that. So let's say we have the function f of x is equal to sine x plus cos x. Very simple function. Let's add in, say, minus 3x squared. Okay, so we have this function here, and we want to find f dash x. So when we differentiate, we find f dash x. Well, all we have is a sum and a difference. We got a sum here, this plus this, and then we got a difference, this minus this. So we just do each bit individually. So let's look at sine x. Well, sine x differentiates to give us cos x. So f dash of x is going to be cos x plus cos x differentiates to give us minus sine x. So plus minus sine x. And then 3x squared, well, that's this rule up here. So 3x squared differentiates to give us 2 by 3 x to the power of 2 minus 1, just using this rule here. So we just get cos x, just to tidy it up, plus minus gives us minus sine x, and then minus 2 by 3 is 6x to the power of 1. So when we differentiate this, we get this. Very, very straightforward. Let's have a look at another example. Let's say g of x is, say g of x is the function, let's say 3 minus cos x. Okay, so we have to differentiate this. So again, we've got a difference, so we can just take each bit individually. So g dash x would be, well, we've got a constant here, and a constant differentiates to give us 0. So we got 0 minus cos x differentiates to give us minus sine x. So just be careful of this minus sign here. So when we differentiate cos x, we have minus sine x, but we already had that minus sign in there, which I've written down below. So now we've got minus minus, which will give us plus. So that's really equal to 0 minus minus is 0 plus sine x, or just sine x. So when we differentiate 3 minus cos x, just using the rules that we have over here, we get sine x. It's very, very straightforward. Let's have a look with a simple one with, say, tan in it. So say we have h of x is equal to, let's say cos x plus tan x. So that means h dash x is equal to, well, we just got a sum here. So differentiate cos x and I get minus sine x. So minus sine x plus, and then differentiate tan x and I get sec squared x. Sec squared x. And that's it. Very, very simple differentiation of trigonometric functions. Okay, let's look at a slightly harder example. So let's say we have let's say f of x is equal to, let's say, sine x over cos x. So f of x is sine x over cos x, and we want to find f dash x. So first thing you'll notice is that we have a quotient here, so we have to use the quotient rule. So the quotient rule says, if you remember, it says if f of x is equal to u of x divided by v of x, then f dash x, this is just the quotient rule, is v of x times u dash x minus u of x v dash x all over v of x squared. So the top bit here is u of x, the bottom bit is v of x, so we just have u of x is equal to sine x, v of x is equal to cos x, and then we can find u dash x by differentiating this. So u dash x would be, well, let's look at the rules. So sine x differentiates to give us cos x, so that's the one. So when we differentiate this sine x, we get cos x. We want v dash x, so cos x differentiates to give us minus sine x. So when we differentiate this cos x, we get minus sine x. And now just fill it into this, so f dash x will equal v of x, so cos x, multiplied by u dash x, so multiplied by cos x. So that's going to give us cos x squared, minus, and then we have u of x, which is sine x, multiplied by v dash x, which is minus sine x, so minus sine x, all over v of x, which is cos x, all to be squared. So we can simplify that down. We know that cos x by cos x is cos squared. So we have cos squared x. Cos x, it's cos x all to be squared, which is the same as cos squared x. If you remember, cos x squared, another way to write that, simpler way, is cos squared x, minus sine x by sine x. So that's it's a minus by minus, so it's going to give us a plus. And now we have sine by sine, so we have sine squared x, all divided by, and another way to write this at the bottom is just cos squared x. So again, very straightforward. We use the quotient rule for this, which is over here, and then the rules to differentiate trigonometric functions that we have here. So now we have 1, 2, 3, 4, 5, 6 different rules.